Hello everyone, welcome back to Open Source Med. This video is going to be the second part of an ongoing series for our open source CPAP project. We're going to take a look at how exactly a CPAP machine works and all the various electronic components that it utilizes to give you a restful night's sleep. Today we're going to be taking a look at the AirSense 10. This is a generation behind the current AirSense 11, but still relevant enough and used by still hundreds of thousands of patients. So it's going to be a good indicator as to what kind of electronics that we're going to be utilizing in this project. So to start off, we'll be taking a look at the main motherboard that you see here. This can be accessed by taking off this front panel and doing some screws, and then you're able to get access through it. So this is the backside of the main motherboard, and then additionally there is another auxiliary board here, which actually sits on the left hand side of the machine where the intake air is for the motor. As for what controls the CPAP machine, we have this main chip in the middle on the main board, which is a 32-bit Cortex M4 CPU. This handles a lot of the main functionality of the board, from interacting with memory, interacting with pressure sensors, and then send commands to the motor, and also interacting with another smaller microcontroller unit, an auxiliary microcontroller, which basically offloads some of the work that the main microcontroller unit has so it can focus on other important things. On that smaller auxiliary board, we have another microcontroller, this 32-bit RX MCU, which interacts with the modem chip, which does a lot of the teleservices for sending data to both your doctor and the ResMed app. So this, in a way, also acts as an auxiliary microcontroller, offloading a lot of that heavy work for the main microcontroller unit to do and just sends the data over to that instead. Next chip that we have on here is for static RAM. So this is basically going to be storing data on the device. Similar situation, we don't know what data they decided to put on this, whether it be, say, image data for displaying on the LCD screen, displaying data for calculations. We don't know, but obviously the main point of it is going to be storing data and such that the main microcontroller or the auxiliary one doesn't have enough space for. There are two pressure sensors located on the main board, one being a surface mount one, which is the MPA 300M, and one being a through-hole component, being the Sensirion SPD8. The MPA is only able to measure pressure, and it does that just by measuring it relative to atmospheric pressure. Typically, units of pressure are measured in centimeters of H2O or centimeters of water. This can handle between 10 to 30 centimeters of water, which is typical for any CPAP treatment. The Sensirion pressure sensor is a differential pressure sensor, so it measures it between those two holes, or those 2 points. It's also able to measure humidity as well, giving us data such as that. Now, if we move slightly up the board, we have two other main components. One being a watchdog timer, and then we additionally see we have a SD card adapter there for taking in data as well. Now, the way a watchdog usually works is that it basically monitors the status of the main processor unit by basically just receiving timed pulses. So if it doesn't receive a pulse within a certain amount of time, we can know that we need to reset the main microcontroller as it's not operating properly. I personally like this graphic just because it describes it in a cute and really easy way to think about. The chip on here has some additional functionalities if you look at the data sheet, but really we could take away the main point that we send over, or the microcontroller sends over periodic pulses to the watchdog timer, what we call a stroke. If the MCU is malfunctioning, if we don't receive a stroke within a certain amount of time, it resets it. If we take a look at the second board on the CPAP machine, we see we have a wireless model chip that can handle up to 2G/3G communications. This is used to relay data to whatever service provider your doctor is using to monitor and get your data, along with sending data to the ResMed app, which displays a lot of the data such as AHI, amount of hours slept, and other things too as well. So that's going to be another piece of the puzzle for us to solve. So combining all these various functionalities together in a system diagram, we see in the middle we have the main brains that will be handling all the different functionalities of the board. Our motor controller, going from motor controller to the 6 MOSFETs, which then drive the motor. We have our watchdog timer, a display for displaying information, pressures for receiving information, giving us indications on how fast that we need to spin the motor to receive a certain pressure, a RAM chip for storing data, an SD card for also having data on there as well, and then additionally 2G/3G communications for relaying that information to our provider. Now, based off that previous system diagram, an open source solution really gives us a lot of ways moving forward in terms of providing improvements to the CPAP machine. Whether it be from just giving it a larger screen that's touchscreen that patients can utilize and interface with their data, all the way to introducing new functionalities, sensors, ways of interpreting your data, and then getting recommendations on further treatment plans. It really gives us a lot of leeway that we can start experimenting to give better quality treatment to patients while opening up this knowledge to an open source community for them to continue iterating and making better quality systems that we can then go and get certified. In the next video, we'll be taking a look at the open source electronics that we plan on utilizing for the project and some current testing that we're going to be starting on for the algorithm and motor controller for the CPAP machine, along with some ideas for the CAD model that we're using to introduce building and simplifying the overall construction of the device as well. Stay tuned for next time. Thank you.